have a hash of a tree, and then another two buses that makes it across the board. And then the directory is so much page. Things like that.
Bruce didn't work, and then you get
Oh, you got some gold there. What's that? We're sending decaf the copy over. We have any decaf? There's something happened like so. There's huge
kind of like a
yeah, it's like everyone is part of this. And then the other thing is just this persistence, right? So if we all do this content, we can hash that it'll never disappear. So I guess we're gonna undergrad here.
Yeah.
Right.
I think the for lack of a better way to describe it.
Well done.
Yeah.
It's okay. Really great.
Yeah, but I trust you. Yeah, that's friendly to me.
Yeah,
Hey, how's it going? Alright, 7:06, started. Thanks everyone for coming, especially newcomers and repeat comers. So this is number 2, so haven't established much of a group yet, but thank you. This is Triangle Open Source Open Mic. I just want to go through some ground rules real quick, in case you're new and weren't here last time. So these are all lightning talks. So the idea is, if you're here in the audience, you can come and hear lots of different talks instead of one long, boring talk. So try to target about 5 minutes, but 5 minutes is a little short. So some topics warrant a little more discussion. So we set the hard limit at 3 minutes. And after all the talks are done, we'll have time for just mingling and talking and saying, hey, that was awesome, tell me more. As far as topics go, it's called Open Source Open Mic. So it should at least be loosely related to open source technologies, but how you make that connection is, we're pretty loose on that too. So if it's something on GitHub that we can look at, or if it's something we can download and play with, hack on it, good enough. If it's something you made yourself, that's even better. Questions. If you have questions for the talk, just wait till the end of the talk instead of interrupting, since we're trying to go fast. If your question is super specific to something you're doing and no one else is going to care, just wait until after the talks are all done and do a one-on-one. And have fun. We got food, we got pizza, we got some drinks, we ran out of beer, sorry. We got water, coffee, tea, but no decaf, sorry. But we'll have fun. All right. And I'm recording. There's a little phone up there. And I'll put it on YouTube just like last time. So if anyone's not here, they can check it out.
How was the sound?
It came out pretty good last time, I thought. Did you check it out?
Didn't know that you posted it.
Yep. So there was a sign-up sheet. If you plan on giving a talk, you can put your name on here. I'm just going to take people at random. Once we go through all this, if you feel like you want to get up here and talk, that's cool too. And you don't have to have like an elaborate, planned out presentation. You don't even have to have slides. Come up here and just say some words. So, well, with that said, does anyone want to volunteer to go first?
Did you mention where the bathrooms are?
Oh, the bathrooms are down the hall on the left. Also, there is one more thing. I have shirts for anyone who gives a presentation.
Getting a free shirt today.
So Transloc is partnering with Uber. We're actually having a little launch party tomorrow in Durham, downtown. Woolly Bull will be there,
Yeah.
and the mayor of Durham will be giving a talk. A representative from Uber will be there. Our CEO will be giving a talk, and our app on iOS and Android will have an update tomorrow morning with Uber integration.
Is it more than 5 shirts?
Yeah, I can. There's more in the back.
Otherwise, he's going first.
Does your Uber integration, is it gonna track Uber drivers?
No, the plan is, let's say you're a passenger.
Yeah.
You want to go from here to home. You can type, there's a trip planner going to be in our app now. You can put in your address, but let's say there's no bus stops near your house. You can take a bus 90% of the way and then hop in an Uber, and if your Uber ride is less than some threshold, it's only like $5 max, I think. So that's the plan. So if it makes sense to take an Uber, we'll suggest that to you. If it doesn't make sense, we'll just say, hop on this bus and go here.
Is it gonna request an Uber driver at the end point when the bus is
It will
on?
tell you when the best time to request it is based on your estimated arrival at the bus stop.
That's too cool.
And you can hit it yourself. In the future, the plan is that we'll do it for you, but not on the first release, not quite yet.
And the first release, it only works with Go Triangle. So if you download the app,
Right.
you have to use Go Triangle.
The way we're doing it, this is not a technological limitation, but more of a policy thing. But we're only enabling it for agencies that agree to do it. And for the initial pilot, it's just Go Triangle, but that will expand pretty quickly. And one is going to be Memphis. They've already agreed to.
Do you have VGA?
Yes. I'm an adapter for VGA.
I can go first. If you, cool. That's okay.
Yeah. Yeah. I thought I was gonna say one more thing, but I can't remember. So go ahead. Mark Hutchinson. I think it's USB powered. VGA.
Well, I do have HDMI, but it's fun.
See if this will work. Menus. The audio.
No.
Plug in the USB.
Hang on a second.
Yeah, audio going through the TV?
There's a little audio plug here, but they didn't use.
I was curious because my presentation wants audio.
Oh, yeah.
Duplicate my desktop.
In the what? Oh, it's powered. Who here has heard of a covering set? Okay, before I can begin, let me explain. A covering set is when you have
We have to start the timer.
no, set the timer when I actually do when I actually start the presentation. The lightning talk. This isn't the lightning talk. This is the pre-lightning talk. the preamble to the lightning talk. So if you have two sets of things, what is the fewest number of items in one set who have an inclusion? They are in some part of another set. What's the fewest number of these things in which you can have membership in at least one of every one of these? So this kind of with the minimum covering set of A to B. And answer questions out on expertsexchange.com, and somebody asked a question in the Python forum. Last Thursday, I did a lightning talk. This is actually 2 lightning talks. Part 1. Can y'all see this? So it's to show the how to calculate that. I'm also going to include how to sort a Python dictionary object based upon the length of the value, not the key, but the length of the value, which is going to be a list. And then using a method within the iter tools library, show how to iterate through the different combinations until you find what you want, until you find a solution. There is a second part to this, if I'm permitted to, which I did a performance test of different ways of finding, is this item in this list? And I made 4 different types of performance comparisons. If we have time and people were interested. So, import iter tools, very important if you want to use iter tools. I have some sentences, so I've got a list of sentences here. This was just part of the problem that was posed to me. Anybody heard of stop words? When you're doing creating an index for a document, you don't want to include the little bitty words like a, and, the, any, many, most. Those are considered stop words. So when you are looking for words, you want to look for significant words. And what I had to do was, or wanted to do, was to eliminate the stop words. So I went on to Wikipedia or somebody and said, give me the stop words, English stop words. So there's about 119 stop words. Once you get to about 100 of those stop words, you'll reduce any sizable text in half. So the first 100 words of these stop words, frequently used words, comprise 50% of our language. So I want to eliminate that. So here I am enumerating these sentences and lowercasing them, splitting them by the space characters so that I get the words, and I just check to see if if the word that I'm looking at is not in stop words, so it's a significant word, then I am going to populate my dictionary either with a new item, or I'm going to append the position which sentence I'm in for the existing key, and the word is the key. Here, using the sorted function, I'm going to take that dictionary and I'm going to sort it by the length of each item. And the length, remember, or the value of each item is a list. So it's the length of the list. How many sentences did this word appear in? And I want to get the most up at top. So I'm going to sort these in reverse order. So words occurring most frequently in terms of sentences up top, least sentences down at the bottom. Here's where I get into the covering set. The covering set is actually the number of sentences I have, the index, 0, 1, 2, 3, 4, 5, I have 5. And if once I get to some combination of words that actually covers 0, 1, 2, 3, 4, 5, or 1, 2, 3, 4, I can stop. I just set a flag, stop my iteration. So here's the InterTools combinations. The InterTools has combinations and permutations, and when you're doing something like this, you don't need, well, this word could appear first or second or third. It's just what's the combinations, the unique combinations of words that you have. So this is going to automatically give me those combinations. 4 of them or 5 of them. Is any word actually, occur 5 times or 4 times, 3 times, 2 times? It's that. Or does one word cover all 5 sentences? Do 2 words, any combination of 2 words, cover all 5 sentences, 3 words, etc. So I'm building up this list and comparing it to my covering set to see whether or not it works. I've got a coverage, and when this runs, it extracted from those test sentences I had up the top. Experts Exchange is a nice site. There are a few sites like Experts Exchange. Google is a search engine. I can search for anything in cold date. Once I've deleted or removed the stock words, I have engine occurs in the 3rd sentence because this is the index 2. Search occurs in the 3rd and 4th sentence. Anything occurs in the 4th sentence. Expert occurs in the 1st and 2nd. Exchange in the 1st and 2nd, etc. Oh. That might make it easier. So just as a way for me to know what I'm doing along the way, I put some print statements in here, and then after I've sorted by the length, this is the thing that I'm going to be making combinations of here. And when I go through and check it, I get the words search, expert, and cold covers all of my 0, 1, 2, 3, and 4 sentences. So the InterTools combinations made it really easy for me to go, here, what are the combinations? I didn't have to code up that combinations thing. How many items do I want in a particular combination? And it did it for me. It's kind of nice. Yes? No? Questions?
Could you go back to the implementation?
Hmm?
Could you give us another look at the
Sure.
implementation of the iterating over all the combinations part?
So, how many words do I want to look at a time? How many at a time is my word count, and that's going to be fed into the combinations method. I'm going to take, one word at a time from that sorted dictionary, 2 words at a time from that sorted dictionary, 3 words at a time from that sorted dictionary, etc. Then build up a set, build up that list of what those words represent, or what sentences they're in. And this is out on, I will post it in the meetup. My GitHub account, try Python 2016-02-25 Lightning Talk. And I'll post that link out there so you can see it, play with it.
Dave, just in time.
Question?
At your intro, you mentioned EE problem, which I translated as
The which?
It says at the top of your program, EE problem, does this have an overlap with electrical engineering, or is that?
Oh,
just
no,
engineering?
experts exchange.
Okay. Okay.
Which is where the question was first posed. I have a very short second lightning talk while I'm set up here, which is comparing different search methods for a list.
We have a lot of people, so that's maybe at the end.
Okay.
Any more questions for Mark? When they start with space.
Okay. But I want to get 2 t-shirts.
No, just one. What size do you need? Extra. I'll have to go to the back.
No, you don't. Mike. That's that.
Oh, the new stack? Ryan already. Extra large.
He recognizes rotundness when he sees it. Just stay plugged in. Right under the wire.
David, you want to come up?
Sure.
Plug in. Yeah. Whoop. Other side.
Yeah, actually different.
This is David. He works at Transloc with me. Yes, he's talking about the Pebble Smartwatch.
Yes.
So we both own one.
Get excited.
Yeah.
We have different models. All right. So I'm David, talking about the Pebble Smartwatch. I got one recently, so I've been hacking on it, and it's been a lot of fun. And I wanted to share it with you guys. So Pebble has 3 different models that they've made. I think they originally kickstarted maybe around 5 years ago. So that was the original Pebble. It has a black and white ink screen, which is pretty cool. So it has really low power usage, but you have this always on display. And then I think maybe a year or 2 ago, it was another Kickstarter. They did the Pebble 1, and that one has a color screen, so it was like really exciting. And it has a better API too for functionality and stuff. And then they also made it's also the Pebble 1, but it's just a round watch face version of that. That one's a bit thinner and has lower battery life, but same API and stuff. So the Pebble operating system is built on top of the free real-time operating system, which I'd never heard of, but their site says it's the de facto standard solution for microcontrollers and small multiprocessors, or microprocessors. So it sounds exciting. But Pebble uses a lot of open source software, and they publish a lot of it, which is really cool. So on their GitHub account, you can see all sorts of tools that they built, including Cloud Pebble, which is their IDE, which I'll show you guys in a little bit. They also have different libraries you can use. There was QEMU, which is a emulator. They built on top of that and open source their fork of it, so you can run an emulator when you're developing. There's some like Node API stuff. There's tons of stuff. I might actually open it up because, well, I guess it's in no particular order, but I don't know. They have a lot of interesting stuff. I still want to explore more of it. I'm trying to think. Yeah. So there's a bunch of different ways to write software that interfaces with the Pebble. There's if you want to write like native code, you write it in C. So that's the part that you compile and actually put on the device for displaying stuff. You can do a watch face, which is like a persistent app that's on the home screen, or you can do a bunch of other little apps. There's tons of them that people have written. There's an Uber one, which is pretty cool because you can request an Uber from your watch. There's I use the Swarm one, so you can like check into places. There's all sorts of, I'm trying to think what else. There's a Wunderlist app where you can like add your Wunderlist and things like that. There's also iOS and Android SDKs. Runkeeper has a cool integration with their Android and I think iOS apps where when you fire up their phone app, it just switches over to the Pebble app on your watch and shows you stats and stuff like that. There's also PebbleKit.js, which is the a JavaScript portion that runs on iOS and Android. That's something that really attracted me. It allows you to write some JavaScript code to fetch data from the internet or get location services and things without the use of a native iOS or Android SDK. So you're able to write Pebble apps that run on iPhone and Android without having to know how to code for those, which I do not, and it takes a lot of time to learn, so this was a cool kind of workaround for me for that. And then they have Pebble.js, which is writing JavaScript that I think actually just like compiles to C, which then you compile for the Pebble itself. I haven't messed with that but it seems interesting. So when you're working with the C API, these are some of the ways you can interact with the Pebble. They have a messaging system to speak between the phone and the like your phone and your watch, and that's you can talk with JavaScript from one side and see it to the other. There's Wake Up, which is just setting timers. So if you want to set an event that you know it's going to happen later, you can have your app wake up at the time. There's pretty cool animations you can do. The screen actually has a pretty high refresh rate, so you can get some really neat fluid animations as you change between screens. You can flip the backlight on and off. You can make it vibrate at different amounts. It has an accelerometer even that you can pick up information with, and even there's certain triggers you can do. So if you shake it, you can have different commands run or different stuff fire up. And then it has voice translation too, which so far I found is pretty good actually. So it's neat. So if you want to respond to like a text message or something, you can use the voice. So real quick, I'll show you guys what this SDK looks like online. Let's see. I haven't messed with it much, but it's actually really cool. And this is an open source piece of software that they wrote, but it allows you to edit your C code. Here is a weather watch face I made. So you can write your C code that runs on the watch, write your JavaScript that runs on your phone. I have it doing AJAX requests to, let's see, it's like forecast Joe's weather API, and then you can compile and run it in the emulator online and see what it looks like. And in fact, I realized today you can even, if you're logged in on your phone in the cloud SDK with the same account, you can push it right to your watch through this website, which at first I couldn't figure out how it was doing it. It was kind of magic. Reboot the emulator, of course. Live demo.
It's a feature.
Yeah, it's amazingly consistent how demos do that. But I really enjoyed it, and it was just really neat to get something I could program. My wife has an iPhone, I have an Android. I thought I'd never be writing software that both of us could use on our mobile devices, but it was an easy way to do that, so that was pretty fun. Here we go. So this is, I saw an Android app that works similar to this. I thought it was cool. So you get forecast for upcoming hours. They also just added hooks into their health API, so it's always tracking your steps. And so I have this green ring. I don't know if you can see it in the back, but it shows how close you are to finishing your goal for the day. So you can keep track of that. But yeah, do you guys have any questions about it, or sure?
Yeah, like lots of questions. I have seen smartwatches that go directly to the internet, but this goes through your phone with Bluetooth, right?
It does.
does it have any other interfaces like Wi-Fi or no?
No, it's just Bluetooth.
Okay.
So you're always tied to your phone. Yeah.
And is the only way to prep programs in the cloud, or can you do stuff locally on your own machine?
Yeah, there's a local SDK you can download, and that's the only way I had done it. And I realized they had this and probably be better for presenting, but when I started using it and saw how easy it was, I thought it was pretty cool. It can also push and pull code from GitHub, which is nice. So you can grab other people's projects, try them out. In fact, I was able to start writing software for it before mine showed up because the SDK was easy to set up and the emulator worked well and stuff. So.
And one last question.
Sure.
I'm in an IoT group, and we're always talking about, at least I'm always talking about the security aspects of cloud prepping something and being able to push it directly to a device. It seems like a security hole.
It does.
And
Yeah.
I'm wondering, did you explore that? And do you know anything about the security of getting certified code to your Pebble?
No, I haven't, but that's something I did. Yeah, I should look into more. That's a good point. Sure.
How sensitive is the accelerometer?
It feels pretty sensitive. So as far as like, they have a couple demos where you can kind of tilt it around and roll. It seems pretty good. And I've been wearing a Fitbit also, and my steps were matched up fairly well. So as far as what it judges as steps versus not, it seems pretty accurate.
Okay.
Just from my experience.
Kind of to follow up on what Mike said, I saw a hacking vector or a security threat vector of somebody who was wearing a wrist device with an accelerometer, and they were able to see what the left hand was typing.
That's interesting.
And then through the pauses, they were then able to guess, okay, what would the right hand be? What would we fill in here for the missing letters? It's like,
Okay.
yeah.
So everybody, right hand only passwords, right?
Just doing your Fitbit around your ankle.
Either that
Oh,
or
yeah.
just use your other hand and do one key.
Cool. Oh,
You mentioned voice transcription or microphone. Is the microphone on the watch? Or is
it is, yeah. So you can still have your phone in your pocket and say like a note or whatever. I use it to add grocery stuff to my Wonder list. So it's one of those easy things to forget to do in the moment, but I can just fire it up and
Is
say
most of that processing being done on the watch or your phone?
I believe it's the phone because I don't think that API works with that Bluetooth connectivity.
Does it leave the mic on all the time, or can you shut it on?
It's only on when you switch it on. Yeah, there's no voice activation. Or anything like that.
Is the vibe just a single frequency, or can you change?
There's different. I know you can script different like combinations. I don't know if there's different intensities, but you can kind of say vibrate at these at this these times, and we'll go through that rhythm that you set.
Did you say the display is always on?
Yeah, it's e-ink, so you always have some display, and then there's like a backlight. It has a light sensor, so it knows if it's dark enough, it should turn the backlight on when you start interacting with it.
And the battery's pretty good. Like that.
Yeah, so I think the one Michael has, it's probably over a week, right? Maybe 2 weeks.
No, but
Okay.
probably like 5 or 6 days.
Okay.
Yeah,
But
I think mine
when it
averages
gets-
about 5 days.
When it gets really low on battery, it switches into another mode where it just shows a clock, but you can't do the apps or anything else. But then it'll last even longer, but I haven't figured out how long.
But it's rechargeable.
Yeah, it just
Okay.
has like a little contact, like magnetic contact in the back, and just like it's
Does it work for all 3 of our models? I know the iOS SDK works for all 3 models. Does Cloud Pebble, or do you know?
It does, but I don't know how much smaller that original like SDK is. Like, you can build to all three types at the same time, but I don't know what's included only in the newer ones other than color, obviously. So.
Right. Yeah, mine does.
Cool. I think my time's up. So.
Let's see.
Between us, we have all 3.
Dave?
That sounds cool. You're plugging in yours, right?
Yeah. Plug the audio too.
What? David doesn't get a shirt because he works here.
Yeah, I already got one.
Let's not.
That's pretty sweet.
Well, let's do this. Well, this might be loud enough. Okay, so I'm going to talk about Alda. Alda is a music programming language that I created. It's been kind of my pet project for the last 3 years or so. And so a little background on the project and why I created it. I was a composer a long time before I was a programmer. I've been working professionally as a software developer for about the last year and a half or so. Before that I was doing something totally different, and my degree is in music composition. And I've always been interested in ways to create music by programming. So this kind of led me down a path of like, what's the ideal way to compose music using kind of like a programming aesthetic. So basically, this is a way to compose music in a text editor. It's like at a very basic level, it's like a way to represent a musical score in the form of text. And it has a parser that will parse that text into a form it can understand, and it'll play it to you. So I guess I'll just give you a basic demo of it. I didn't really structure my talk around slides, just figured I'd kind of take what little time I had to give you a little demo of it and kind of walk you through like how you might write a score using Alda. So over here's my text editor. You guys see this okay?
Yeah.
Okay, so this is Alda syntax. And you can use the Alda command line client. Actually, I'm going to restart it again because there's a bug I've been working on fixing. Bear with me. Takes a while to start up the first time, but it's pretty much immediate. So you can play a little bit of code like this. Or you could play code from a file, like this demo file I have over here on the right. You might recognize this tune. So that's kind of a basic overview of what you can do with Alda. So we have a score over here that has a couple of different instruments. There's like an organ sound, and there's a percussion instrument, which is constructed kind of like a drum set type thing out of that. Currently, the only instruments we have available are the 128 general MIDI instruments. So this is a way to compose MIDI scores. It's still a work in progress, but we basically have the foundation laid for a lot of different types of things to be done with a score like this. Like eventually I'd like to be able to export this to like written sheet music, for example. And I also have plans to do things like implementing like a synthesizer instrument. You could build your own synthesizers out of different waveforms. These are all kind of like future plans laid out. But right now it does, I think, a pretty good job of composing a MIDI score. So I've got a couple minutes left. I'm going to show you the Alda REPL. By a show of hands, how many of you here have programmed in Lisp before? Oh, all right, about half of you. It's awesome. So I'm a big proponent of Lisp, especially Clojure. And one thing I really love about Lisp is the REPL-oriented development flow. There's this thing called a REPL, which stands for the Read, Evaluate, Print Loop. And it just gives you a really tight feedback loop while you're writing a program. You can type in a form and kind of see what it evaluates to, and just kind of work on your program interactively, instead of writing a whole thing in a big IDE and then running it and seeing what happens. So you're able to develop a lot faster that way. So I wanted to bring that kind of a workflow to Alda as well. So this is a way that you can kind of write a score interactively. So a very basic score, this is sort of like a hello world, if you will, of Alda. I've created a piano instrument and played a C on it. So you can do things like, by default, the notes are quarter notes, but you can change them to eighth notes or whatever you'd like. So once you put a number at the end of it, like this is saying this is an eighth note C, the eighth note then is kind of persists for all the following notes. So all the following notes are also eighth notes. And then when you get to the top of an octave, you can jump to the next one with a greater than. So octaves are also persistent. Now we're actually in the octave up. You can also have chords by putting slashes between notes, like this. You can have multiple instruments in the score, like, someone call out an instrument. What instrument going here?
Saxophone.
Saxophone. Tenor sax, alto, or bari?
No.
Sax. Say like octave 3 maybe, or 4 is good. You have like a D sharp maybe.
Can you set up the attack and decay specifically and create a custom instrument, or just the instruments that?
Not yet, but that's something that we have planned for. I want to create like kind of an easy way, sort of like an API for creating synthesizers, and you'll be able to apply filters and things like that.
Do you have a whistle instrument?
I think there's a MIDI whistle. Let's see, whistle. Oh yeah, there's a whistle.
Can you do theremin?
Don't know if there's a theremin.
So, do you know the theme to the movie Buckaroo Banzai Adventures in the Eighth Dimension?
I don't.
That is really cool if done in a whistle.
How about Close Encounters of the Third Kind?
Oh
We'll do
yeah,
that one.
sure.
Like tuba maybe? Let's try tuba. Yeah, that's my time. Do you have any questions?
So at the low level, where are you working in what layer? I mean, for the, like in Linux, you know, you got all these starting with.
Okay, yeah, so this is I program a closure. So the back end, the server that's running here, you saw up above I started a server. It's a closure process. So it's running on the JVM, the Java Virtual Machine.
Okay.
And so I'm accomplishing this MIDI stuff by, the Java Virtual Machine is a built-in MIDI synthesizer.
Okay.
So I'm just communicating with that. Mark?
Are you going to go to Moog Fest?
No, it's kind of out of my price range maybe, but it's pretty cool. Wish I could go.
What if you got on stage as a speaker, a presenter? You might get in free.
They have presentations?
Yeah.
What? Look into that. Do you have another question?
Yeah, I'm wondering, so is there a JavaScript library for this already?
Not yet. There needs to be one though. So I don't know how familiar you guys are with Clojure, but there's a variant of Clojure called Clojure Script, which compiles to JavaScript instead of Java. So I'm looking at ways to make sort of a go-between layer that will allow you to use it from both Java and JavaScript.
Can you explain some of the syntax that you didn't cover in REPL on the right?
Yeah, so there's various things here. This the square brackets syntax is a way to group note events together. So this is kind of like a phrase that we've grouped together, and then there's a repeat operator, the asterisk, that you can say, repeat this 6 times. So this is in the percussion part. We use this to kind of build up like the drum part, and then just say repeat that 6 times. I showed you the numbers at the end of the things represents how long the note is in standard musical notation. Minuses are flats and pluses are sharps.
Is it polyphonic?
Yeah, I showed you there's a chord.
Okay,
chord.
okay.
Sorry?
You played a chord.
Yeah. We're in the tuba now, so this is going to sound absolutely terrible, but oops.
Okay. So you can play a chord. Can you play an accompaniment? Is it, I'm thinking like multi-threaded where you could, you'd have a background
Oh, yeah.
playing and then,
I don't know if there's another example of this.
Well, you had that in the first sound, right? You had your percussion in the background?
Yeah, I don't have any chords in this particular example, but it's possible to write piano parts. And an easy way to do that is there's a way to use voices. So that's this V1 and V2 syntax.
Oh, okay.
Yeah, so this is like you have 2 parts going on at the same time, and this is like sort of the abstraction for this organ part. The keyboard cat is playing with his right paw the melody, and with the left paw he's playing a bass line. And these parts both start at the same time.
And is it intuitive how they sync?
Yeah,
When they
as
come
soon
in?
as you start a voice part,
Okay.
they will start together. So voice 1, voice 2, you can have as many voices as you'd like. And then when you're done, you can say voice 0, so you can sync up again.
I'm wondering if you can wait and like row your boat. Can you come in on the 3rd?
Yeah, so
Okay.
another convenient thing, there's an example of this here, is we have a marker syntax. So you can set a marker. This is basically a reference to a point of time in the score.
And then start voice 2, 3, 4.
Yeah, this is something you can't do in standard musical notation. So I feel like this programming paradigm kind of like makes it if you can wrap your head around it, it's I think a better way to program, or a better way to compose music. So in this example, we've set a marker called organ in the drum part because there's a drum intro, and then so we know at the end of this intro we want the organ to come in, and then in the organ part we just say at this organ in marker, that's where I want to start.
And you mentioned Lisp. Is this, it's doing Lisp processing, or is it using like Cooter and Cotter?
No, Clojure doesn't use the car and cutter stuff. That always, I can't wrap my head quite around it because there's always catter and catter and all these things. It just confuses me.
That's real Lisp, by the way.
Yeah, I understand it, I just don't like it. That's all my time.
Awesome.
Feel free to ask Thanks.
Jacob, you ready?
No.
No? Okay. Scott, you ready? Sure.
Medium, please. Thanks.
You work here? I thought you were in a closet full of this.
No, I work at Adzer.
Oh, right.
I do have a handful of Adzer shirts though that I got for free.
Yeah.
How long have you been at Ezra?
A year. Yeah, before that I was working for the state government doing something non-programming related.
Yeah, I'm not new new. Yeah.
Scott Norton. Talking about software-defined radio.
Okay, so so this topic, does anybody, first of all, any SDR experts? Okay,
Not an expert, but
all right.
play with it.
Good.
Play one on TV.
Good to know the audience. So, software-defined radio. Yeah, I got a little into this in like 2010, and I'll show you why. I can show you right there. That's why. Because in 2010, people discovered that, well, you could do software-defined radio for under 20 bucks. So what is software-defined radio? Well, it's basically taking your computer and picking off any RF frequency, you know, from kilohertz all the way up to gigahertz, and being able to analyze those signals in your computer, demodulate them. You know, this can be, and today, of course, everything is digital now. So back in the day, you know, I used to have my scanner in the 90s, and back then you could, you know, listen to cell phone traffic. It was all analog, and you know, you didn't have to do anything crazy. This day, of course, everything. It was good enjoyment while we're studying for exams. But yeah, today everything is digital and encoded, and so this is sort of the next way to go at it, is basically to sniff it out of the air and process it in the computer. And the amazing thing is, this really took off in 2010 from this guy Eric Fry, who was, you know, a typical hacker guy, who sort of proposed this on a forum that, hey, there's this dongle that's actually used for FM DVB. So in Europe, to FM broadcast on the TV frequencies, you could use one of these dongles just to listen to the FM broadcast. And he realized that you could pick off in the computer the IQ channels. That's basically the actual raw samples, down converted from whatever frequency, that raw data that you could pick it off. And he and this other guy, looks like he got cut off. There's another guy, Anti-Patori or something like that, his name, right? Oh, there it is. Oh, it is Pelisari. So he was the one who actually implemented it in the drivers and everything to access this it's an 8-bit stream, it's an 8-bit ADC, but it's super fast. I mean, this thing is sampling at like 3.2 megasamples per second. And of course it has all this, everything comes into the fact that this whole thing this dongle is 2 chips. It's a tuner chip which does all the analog, and basically a digitizer, it's actually 2 ADCs piping out to USB. That's it. That's why they can sell it for like 17 bucks. So going back to, this particular one, you could sample anywhere from 25 megahertz to 17 megahertz, anything near. And so the question is, what can we do with this? Well, of course, listen to the radio. That's like, oh, it's not that big a deal. But yeah, you can listen to any radio. I mean, we're talking anything, and anything that's encoded or digitized. Trunked radio is the classic. So again, back in the day in the 90s, I was listening to the scanner. I could listen to emergency, frequencies for police and everything. Nowadays, if you try to listen to any of those frequencies, all you're gonna hear is, it's like there's nothing there. You can't really do anything with an analog radio. You need digital radio. And so, with $17, and it actually comes with the antenna, you can basically download tons of software out there and basically start to parse this massive data stream. Here's some things that you could do that you would never have thought that you could do with, a little dongle radio. One of the things that everybody does right away is decode aircraft transponders. Actually, I didn't get, I got the link, but I realized I didn't log on to your Wi-Fi yet on this computer. So I'll hold off on that till later. And you can actually receive the NOAA satellite images and actually get, here's an example here. You're basically pulling down actual satellite signals and creating an image map of the weather map from the satellite with $17 dongle. You can do, and another guy, and actually this video, this guy's tracking multiple planes all around an airport using the AIS. Actually, that's for shipping is AIS, and I forgot what the one for aircraft is. That transponder frequency is 1090, but basically, all the decoding, it's all public domain, so it's really just a question of writing the software to decode it. Passive radar. This one, and I have a whole slide on that. Wow, I already hit 5 minutes. This is one of the things we actually use these for at work was we decided to use one of these just to look at EMI compliance with our instruments. So we make medical instruments, and of course, electromagnetic interference is a big issue. And before you spend a couple grand to go send it out to a place to actually look at your whole EM spectrum, you can get one of these for $17 and just get a first look at, if you have any frequencies that you're emitting that might be an issue. And then just, learning cool stuff. So passive radar, this is pretty awesome. You take a radio station or a commercial TV station, and you think about it, if you have 2 antennas, there'll be a signal bouncing off, say, the aircraft, and then there'll be a direct signal. If you have 2 dongles, okay, so you got 34 bucks instead of 17. With 2 dongles, and there's multiple people have done this, they're able to actually track, the location. More dongles you can actually triangulate. With 3 dongles you can actually triangulate. With 2 dongles you can basically get an arbitrary direction. But people have used these to detect planes, detect meteor showers, and to even detect a rotor speed on a helicopter that was flying by. They could actually tell you how fast the rotor was going across. And it's, you're looking at the slight phase changes between these 2 receivers. This basically, again, I'm just saying, it all comes down to this tuner chip, and so all this part of what's super heterodyne receiver is all in this one chip, which basically gets you this demodulated signal that you're actually converting to digital. And this is a typical software. I'm going to do a little quick demo, but this is a waterfall shot where basically you can see the frequencies where there's a strong signal. So the beauty of these things is you can, the more expensive version, this one's a 150, this one's 17. This one can look at a 12 megahertz band, and this one can look at 2 megahertz band. But I can look at the full 12 megahertz bandwidth all at once and see, oh, hey, there's something here, or there's something there, or something there, and I can just put my cursor over it and listen. If it's if it's like an FM station, you can see the whole pretty much FM band, and you can convert to different, whether it's wideband FM or narrowband FM or AM or left side single side band. Anyways, it's all there's HD SDR, SDR sharp. The one that is probably the most interesting is New Radio, which is if anybody's done LabVIEW, where you can basically program just by dragging blocks and linking them together. That's what New Radio allows you to do. So you just create a source. This could be your radio source, and then you basically do all the things that a radio would do to demodulate that signal. And so that's what I will show here. So this is a simple FM demodulator. So this is the RTL SDR source. So I'm basically looking at 101.5 megahertz, which that's the only radio station for whatever reason in this building I can get. And I don't even know from there to here what I'm going to be able to listen to it. But there's a couple interesting things. This program, it has all these blocks on the right that you can choose from, and to basically get the audio sync. So you have a source and a sync, and the audio sync is what you're listening to. So let's just run this quick, and I'm going to tell you something. Same one. One of these. Nope, that's not going to work. This one works. Okay, and now more the truth. Up, volume. Yeah.
Is it coming from your laptop or TV?
Yeah, I can hear some.
I hear something.
Yeah, there's music. There's music.
Cool.
It's very much static. You can hear in the back. But there's a little key part about this. That signal that we heard. Every time I run that program, what it's actually doing is producing Python. So New Radio actually produces a Python program every time you hit compile. And so you can actually, you don't even need to run that LabVIEW thing. You can actually go straight into this. And this is very readable too. And and operate straight at the Python level. And you basically just have these libraries that you can import and set the gain, set the frequency, and just do everything all in Python. So that's pretty much it. And this is a sort of a learning process for me, so hopefully next time I'll be able to give you more details. But actually getting this thing to work with New Radio has been a chore. The driver stuff for this area is still these cheap dongles. Pretty much, there's tons of people have got them working in multiple programs, so that's not an issue. Every time they'll go into anything that's a little more expensive, it's a little more niche. Then getting these open source programs to operate with them, you spend a lot of time just playing with your Linux driver land. So,
you mentioned EMF certification, and I was just wondering, have you heard about Wi-Fi X-ray vision and the attenuation of the signals? It seems like you could use this to set up some really cool experiments where you could use telemetry around the house and look at your baseline EMF and then see it being modified by objects in the house and what have you.
Yeah, except if you had an SDR, and there's some of them that have multiple channels, so instead of having multiple SDRs, you can have just multiple channels, and then you can start getting phase information, and then that's where it really gets interesting.
So the lowest frequency you get is 25 megahertz?
On that particular one, but you can actually go even lower without going, you can bypass a lot of the circuit and do direct conversion straight from instead of doing the down conversion, letting the down conversion part of the tuner chip, there's ways to get around it, and then you can actually sample lower. So it says 25 megahertz, but people have actually gotten much lower with that.
Would the Highway Patrol in Virginia think that you're running a radar detector if you were to pass them?
No, I think it's pretty passive, so I don't think this thing would pick up anything. But the SDRs, you can buy ones that are transceivers, and the hack RF, and people do this all the time. They'll like decode their, you know, and this is where you gotta watch out. You know, the rolling codes for like garage door openers and stuff, and any other, especially these days with Nest and everything else. So there's a lot of home automation. People are using SDR to basically pick up those and the thing they're finding is that these manufacturers are not spending any time
Zero
in encryption.
security.
Yeah, security. So, I mean, you've got to keep aware of that. So. All right, keep your...
Awesome.
Yeah, just push it back.
Chris, Merrill. Yeah. Use IDE website testing. Plug in. Yeah. HDMI. Yeah.
All right. That's who I am. At Web Performance, we spend our days doing performance testing of websites. Either building software, we sell our own software for doing testing, and we also do a lot of performance testing services. So naturally, I end up talking to a lot of QA people. And between a lot of our interactions with them and our own search for a good tool for building automated tests for our own website properties, we've been very disappointed at what we found in terms of a tool that allowed us to very easily automate a browser, test a site, and do that without having to write a lot of code. I mean, we're all coders, we can write code, but we don't necessarily want to write code for simple stuff like click these buttons and make sure that this appears on the web page. There's some tools out there, but we felt like we could do better. So let me give you, I'm going to start out with just a quick demo. And you may not be able to read all the text on there, but what this is going to do is you're going to start up Firefox, and it's going to go out to GitHub, so it's sending it to a URL. Next thing I'm going to do is I'm going to put something in the search term. We've got a parameters tab over here where we can pass in some parameters to our tests. So I'm going to pass in a search term to the browser, which you can see it appeared in there. Then I'm going to submit this form by looking up the form via CSS, and looks like there's a bug in my little locator here, so I can edit that and try it again. And we submitted our search term. Now we can do simple things like I'll add some verification here. So I'm going to look for something by link text. I'm going to look for the link to my project. Run that, we get a happy verification. Next, there's a login button up there, so I'll try calling a login function that I wrote. And this is implemented as some additional steps, so as I get to that function, it will bring the steps in just like a typical debugger, and let me walk through where I'll sign into GitHub here, and then verify that can't really see it here. There's somewhere here there's a sign out button, so to verify that the login actually worked, we'll make sure that the sign out button is there. And then we're done with our test. So, if any of you have ever worked with tools like this, you may be thinking to yourself right now, okay, that's great, Chris, it makes a great demo, but I've been there, done that. I've seen the tools that make a great demo, and maybe they were even great for the first 2 or 3 weeks I worked with them, but then we started to run into all the limitations of those tools. Building in a nice UI is nice as long as it can do what you want, but what if it can't do what I want? Or What happens 6 months from now when I got to maintain all this? Is it going to be maintainable? So those were some of the weak spots in some of the other software that's out there. So those were some of the goals that I wanted when I started building this. So we've already looked at the UI and debugging and looping and conditionals. Some of the more challenging ones was to make it easily extensible and really importantly make it so that you can build a test suite that's maintainable. So those were some of the key things that we wanted in a tool. Extensibility, maintainability, and good integration into an agile workflow. So I've got a couple slides here. We've already kind of looked at that. This is an example of writing a custom step. Every line we ran there, like click or whatever, was a step. So you can easily write a custom step in Java like this, and note this doesn't do anything particularly interesting, but it only takes a couple lines. Note the annotations at the top, which provides metadata for the UI, so that basically you can have a bunch of testers who maybe aren't coders. You can have one tester who can do some coding. He can build a custom step, and they drop the jar file into their project, and the next time they open up the IDE, they'll have these custom steps right there in the IDE. So it integrates seamlessly. All the steps that are built in are implemented just like that. So you can build your own custom steps. They integrate nicely into the UI and allow people to reuse that logic. This is an example of doing it in JavaScript. Hasn't been tested particularly well, but the basics are there to do it. The maintainability was a big one. In this type of testing, you have what you refer to as a locator to locate the element on the web page that you want to deal with. If you have a lot of workflows that use a lot of the same elements, especially like navigation elements, then you get those locators duplicated across lots of tests. And so then what happens when the developer changes that is you get 17 tests to break, and you have to go fix it in 17 places. So one of the things that I built in is the ability to specify a whole bunch of element locators by name in one file. You can organize them by page however you want, and then refer to those from your tests so that when the developer changes that one link, you don't have to change 17 tests, you just change the one place. Just like we would do when we're writing code, right? Make sure that information isn't duplicated all over the place. We already looked at an example of a user-defined function, so the testers who aren't coders can still reuse logic, like the login example that we saw. And these are some of the points that I hit in terms of good integration with development environments. So plain text formats that play nicely with version control systems, command line operation, and JUnit like reports, so you can put it into your Jenkins build or whatever. And so that's pretty much the demo. This is the project status, which is it's very beta. Our open source tie-in here, the IDE is the part that we saw. Everything you saw on the screen was the IDE, which is a free tool, and you can get it there. There's also a nice little demo video. Everything under the covers, which is all the project file formats and the ability to run tests with the command line and run test suites and things like that, all that is on GitHub. And that's it.
Any other questions?
So your app is Muse? Is that what it is?
The Muse IDE, yeah. Yeah, part of what we looked at. That's what that is. Anything else?
Is it cross-platform?
It is written in Java, so yes it is.
Awesome.
Yes it is. It has not been tested on any other platforms other than Windows. But
Try it out.
I don't expect anything to be too much of a problem.
Cool.
Have you found, what surprised you when you were driving Selenium?
So driving Selenium is actually really easy. However, when you're building tests with Selenium, I've actually kind of been down this road on another product iteration for our company. And one of the things we found is that browsers are different. So a workflow or locating an element in one way in one browser doesn't always work another way in another browser. And that's one of the reasons that having support for things like conditionals is absolutely imperative, because you get to a point and you may have to interact with an element that you have to locate different ways on different browsers. Dealing with IE is very challenging in Selenium, although Microsoft is now starting to support the WebDriver specification. So we expect that's going to get better in IE 11 as a blueprint.
And I'm assuming it's performant?
Depends upon what you mean by performant. In the load testing world where we're at, no.
Okay.
When we want to simulate load from 1 million users, no, it's not performing in that fashion because browsers are fat. But in terms of, so they have tools like,
Functional.
in terms of functional testing, yeah. So you have tools like Soloninka Grid, where you can have a bunch of computers all out there serving up the browsers that you need, and you can run your tests in parallel going out to all those. So this was designed to be parallelizable. None of the test suite types that have been implemented yet can run tests in parallel, but there's nothing that would stop us from doing that. Thank you. Yeah. Thank you. Appreciate it.
Well, I'm presenting to, so I'm gonna go.
You just want a shirt.
I don't get one, I'm not eligible.
You have plenty.
I already have one. So I'm going to talk about OpenStreetMaps, which is sort of like the Wikipedia of maps on this collaborative project to create a free editable map of the whole world. If you've ever gone to OpenStreetMap.org, you've probably seen something like this, which is not really a pretty map. Google Maps is way prettier, Mapbox, all the other ones are prettier. But all those other ones don't have open source data. OpenStreetMaps.
That always does.
Oh, my bad. Well, is it based on OpenStreetMap?
Yeah.
So, let's say you wanted to do something with OpenStreetMaps. Well, the first step is to acquire the data somehow. And there's a few different ways. If you just go straight to the website, there's a big export button at the top. So you can pan to any region, and you can just draw a little bounding box like this, and export it to a file. And if you're doing a small area, that's pretty quick. If you want bigger, if you wanted to download like the whole United States, you can't really do that from that source. But there are bulk downloads available on a mirror called GeoFabric. And there's also an API called the Overpass API. So if you wanted to programmatically fetch some OpenStreetMap data, you can do that as well. So now the next step is really to understand the file formats. So if you have a .osm file, that's basically XML. They also have a PBF, which is a protocol buffer format, which is like a binary protocol thing. It's way smaller on disk. XML is like giant. It's important to know that some tools only work with one of the other formats. So you often have to convert, and there's a command line tool for that. You also might want to filter what's in the file. Maybe, because when you download a region, you get everything. There's building data, there's road data, there's sidewalk, rivers, water, administrative boundaries, trees, everything. But like at Transloc, we have a router built on top of OSM data to compute driving directions and driving times. And all we need for that is the road data. So we filter our OSM files this way before we stick
Does
it in.
that include traffic?
No.
Okay.
The next step is, depending on your favorite language, find the parser. Unless you want to write your own parser, there's no real reason to do that, because there are plenty of tools out there to do that already. Here's a few. I haven't used the JavaScript ones, but now this is the really important thing, is understanding what is actually in that file and how is OSM data actually structured. And it's really simple, actually. It's just nodes, ways, and relations. A node is basically a point, a lat long tuple.
right, there could be one right here, and that could be transload, which is the point. A way is a polyline. It's a sequence of nodes. So if you were going to draw a road in OpenStreetMaps, you would have nodes following the curvature of the road, and you would just connect them into a way. And these things all have tags. There's key value pairs. The keys and the values are all strings. And that's how you really tell, that's how you know what is what in the data. So a very common tag is called highway. So any road will be tagged with a highway key, and the value tells you what kind of road it is. And these are the different, some of the different types. There's motorway, which would be like the interstate. Trunk, or like Highway 64 would probably be a trunk. And there's primary, secondary, tertiary, and classified residential service. And on there's an OSN wiki that covers all these tags and when you should use what. And it's all really well documented. So in our router that we use at Transload, we just assign different speed limits to these different categories. Even though it's not guaranteed that it'll be like tertiary would be 25 miles an hour. It's not guaranteed, but there's another tag actually for max speed, but most roads don't have it. So that's the other thing is kind of depend on the data being sufficiently populated, these tags. One-way roads are indicated with a one-way tag. A building is just a way, so you just draw the outline, the perimeter of a building, and you tag it as a building. And you can give it a name. Well, this is a road name, but traffic signals are in there. Some buildings have height, and you know like if you look at New York City, Manhattan, it's very well documented. Pretty much all buildings have height, but if you look at like Fayetteville, North Carolina, or something, it's probably not going to have buildings even.
How big is Raleigh?
It's pretty good. I got some pictures coming up. Here's some sample Python code. If you wanted to write your own, let's say you downloaded some data, a region of OSM data, and this is just a sample that I got from one of the parsers, and all it does is count all of the roads. So you define your own little handler and create a parser instance. And one interesting thing is pretty much all of the parsers run concurrently. Like they'll parse the file in parallel somehow. But you don't have to worry about that. It just calls your little callbacks and it gives you all the nodes, all the ways, all the relations. This particular code is only looking at the ways and it's checking the tags, and if the highway key is in there, and then after it's done parsing, it just prints it out. The ways refer to the nodes by ID. So normally you would have a nodes callback, and you would store, like in a hash table or something, this node ID is this flat long pair or something like that. And then when the ways callback is invoked, you can look up what those were. So now I just have a few examples of some stuff I've done with OSM data. This is Charleston, South Carolina, and I rendered it. This is showing all the roads, and it's color coded based on driving time from the downtown. And I'm kind of made it look like it's glowing. That's pretty good. Here I rendered all of the buildings in Manhattan. This is a zoom in. This is like the whole thing. So you can see Central Park there, and no roads are shown. It's just buildings, and I just randomly colored them from a palette. But you can see Broadway kind of cutting through there. You can see some really big buildings, even barges and stuff.
It's a little loopy line going on the left
That's
there.
some kind of, I'm not sure. I wondered too, and I looked at one point, but I forgot.
Is it the Highline?
Yeah, I was gonna say.
Yeah.
I want to print that like a poster or something, but I haven't.
You make some money on that.
And then I made it 3D, I already had it in my code. But like I said, there's height information for most buildings in Manhattan at least. And that's what this is.
With a certain level of sea rise.
Yeah, I didn't render land. I just didn't render any land. I was lazy. Sorry. Or this is Manhattan in like 100 years.
Probably gives a pretty fancy render for that, right?
Yeah, I used my pathways. And this is Raleigh, same concept as the first one. You can see
See the belt line.
Yeah. Here's 440. Here's 540. There's the airport. And we're around here somewhere. So, I have like 45 seconds. I just want to real quick. One easy way to kind of get started. If you just go to OpenStreetMap.org, you click Edit. And it'll ask you to sign in. I'll just use my Google account. And you can use a satellite view, which is helpful if you're like tracing a building or something. But if you zoom way in, it shows you all the stuff that's in the data. And you can just hover over things. So this is a residential area called Brighton Woods. Or over here is a stream. And there's all this, a lot of this stuff is like programmatically entered from a database somewhere else. And so this has a source called USGS, NHD, whatever that is.
US Government Survey.
There you go. Here's some buildings. Building, yes.
Does any of that include census data?
I think so. So, this, well, that's a railroad, I think. No? Yeah, it's a railroad. It is not electrified. It's operated by CSX. So there's all kinds of cool data in here if you just poke around.
So I could like go to my house and like put awesomeness level 5,000.
Yeah. I don't know if people review the changes or not.
I was gonna ask that, who moderates the updates to open data for
There's
OpenStreetMap?
probably some neurotic people out there who. So here we got a whole bunch of like fast food. There's Piercing Pagoda. So
Does that building get have height right there?
building retail, I don't see height. Hours of operation. So obviously some tags are way more popular than others. So it's just, you gotta kind of look at what's there and see what's useful.
Can you run queries by any of the tags? Like I want all buildings above 50 meters in the city?
I don't think from the website.
For the website.
Isn't that what the overpass
Well,
was
it's a
for?
search, but I don't know how that, I haven't tried. If
Yeah.
I was gonna do it, I'd probably write a script to parse through and kind of collect some statistics on whatever keys there were.
Surprisingly, this is the most mature tool ever for OpenStreetMap. So if it's not provided on here, it's some obscure open source library.
When you have an overpass, how can you tell which road is on top? Or can you?
Let's find one. Here's one.
Besides what it says.
See the shot?
Yeah. Buck Jones Road, Secondary Road.
I think we actually can search. I think we have like a search sequence.
Bridge.
Bridge.
It's a bridge.
Yeah.
So that, they even, the way only is the bridge part. See,
That way, okay.
from here to here.
Cool.
So,
Well, there's some places where there's an overpass over and overpass over and overpass. I mean, is there like a Z index you can set?
Ah,
You know, what's it called? Now,
There's a place like that in
Francisco.
Connecticut.
Yeah.
Seriously.
Go to,
sorry.
oh, so there's this app called CityGram that the Open Code for America utilizes. And it's a Rails app, but it ingests city data and then it lays it on top of like Google Maps. And I'm just wondering if there's any integration for open city data in OpenStreetMaps.
I don't know. Like I mentioned, a lot of people will import a huge data set into OpenStreetMap so that all the data is there.
Yeah.
But I don't.
And it's an overlay.
So, I mean, this is stuff like police reports and building permits and things like that for operations of the city, but also park operation, you know, what is your favorite park open, and, you know, look around and stuff.
Yeah.
I'm guessing there's a bunch of bandwidth charges that OpenStreetMap has to pay for, so how are they keeping the doors open?
I haven't seen them begging for money like Wikipedia. But
Mapbox.
And Michael, so you were saying like if you have a large region and you want to either retrieve or export that, if you're only interested in like motorways or the towns over the whole U.S., is it possible to retrieve just that without downloading like everything?
only if someone like created that for you and is providing it from a mirror, like that geofabric thing.
Mm-hmm.
And I'm out of time. But.
I don't think the moderator's going to be.
Yeah. Out of time. Talk to me after. All right. Let's see.
Ladies and gentlemen.
You want to talk about Electron? Sure. Almost said Adam.
Yeah.
Adam, Electron.
I think it used to be.
What we got?
I got either HDMI or VGA. Mode. Oh.
It's thinking.
Oh, yay! Let's see, can I do it one more time? Yeah. Okay, now I can send you. So, I love talking to people about something that I know very little of, because they always give me some bright ideas about how to go further and answer maybe some of my questions. There's this group, Logical Advantage. A friend of mine, Dan Thayer, works for Logical Advantage, and they have the Charlotte IoT meetup. And Dan also has what they call Tech Talks. And I go to a lot of meetups to learn interesting stuff. And this particular one was on a subject called Electron. And I had confused it with a hardware device that they're going to sell for IoT, Internet of Things, called Electron, which is it's like an Arduino with a cellular interface, okay, that runs on a battery. So I came in expecting this IoT presentation, and no, it's completely different. But it's about JavaScript, and I'm trying to get into JavaScript. So who knows what Electron is already?
I know Carl.
Okay. What's really cool about Electron is if you're into JavaScript and the whole Node.js paradigm of building web apps, Electron builds desktop apps with the same paradigm. So basically think of your front end and your UX in JavaScript, and maybe it's an Angular app, maybe it's a Bean Stack or whatever, and it's running on Node.js, and it's being served to the web. Instead of this, Electron packages the Chrome browser, the Chrome app, and adds the Node.js backend along with anything in your desktop environment, your OS environment native, that the Node.js can interact with, like MongoDB or basically any of your file system and stuff in the backend. And now you can create I'm just going to talk a little bit to getting started. Let's see, I was at the top of this. This is the Electron website. And by the way, I had seen a presentation, but I've never done anything with Electron. And I just paged down to the bottom here, and it shows you the quick start. And the reason I knew I could talk about this tonight is because I went to my Node command line, and somewhere's up here, and I'm just gonna scroll up on these commands, and you can't see them. But there's, here's the GitHub for the Electron Quick Start, and I just cut it off of this page, which is at the bottom of the Electron website, pasted it into my Node.js environment, and by the time I got to the bottom, which says the Node Package Manager install and then Node Package Manager start, and I'm just going to do that last part here. I'm just going to do it. Oh, I'm not in the right directory here. Oh, so when it's starting, I'm in the Chrome DevTools. So it's starting a Chrome DevTool. You know, the Chrome browser has development tools, and if you put your Chrome browser in debug mode, you can create a desktop app that runs the development tools, so you don't have to take up real estate on your Chrome browser, which is kind of nice. Now, I didn't know that tonight until I was playing around in the back room and looked at different GitHub packages for Electron, and this was already pre-built. All I had to do is GitHub into a directory, do an np a Node Package Manager install and a Node Package Manager start, and up comes the is there? Finish last week. I thought this was going to start and show me something. Okay. I don't know why it's gulping, and it looks like I can't Control C out of this either. Oh, wait. Oh, there it is. But it's really slow. I can slow back and back and so I don't consider that very representative of.
Does it require an internet connection?
I don't think I lost the internet. No, I still have the internet. I don't know what's. I see my files. Okay, and what it tells me right here is that it can't find any targets. That's because my Chrome browser isn't in debug mode. But you can see all the development tools of the Chrome browser now are in its own window, which is, you know, I think really cool. But there's all kinds of apps. I was asking, can you do D3 in JavaScript? Because I'm interested in this library D3 in JavaScript to do all kinds of graphic apps and stuff. And I think JavaScript is kind of innately enabled for UX. So I look at it as building in JavaScript is kind of the cool way of doing hotter desktop apps. And the really cool thing is that now your apps can run anywhere. They can run on the Mac, they can run on Linux, they can run on your Windows environment. Anybody who has Node.js, and now they're working on Node.js for Apple and iPhone, and you'll be able to just take your apps and run mobile apps. And you know, basically, this is almost more portable than, you know, than anything I've seen. Are there any questions? I don't have a lot. I could show you this. I could start this out. That's what I was going to do.
So I think GitHub created that editor called Atom.
Yeah.
And I think they pulled this part of it out and packaged it up as Electron. Is that right?
That's my understanding too.
Like anyone can do this now. Like build a native app using JavaScript.
Right. And the other thing I was talking about, what I didn't understand in listening to the developer at Logical Advantage Tech talk is, as he talked about this, I looked at it and I said, oh, you're doing a web app, and then he was talking about integrating with his file system. He had this really cool file system explorer that used D3, and it showed you a decomposition of your file system based on space. So it did a graphic based on space, and you could hover on sections, and you could double click and beam into it. And it was a really neat app, and I said, I'm always focused on the security. I said, well, Electron is taking a web app and, you know, giving the rest of the world access to your file system. That doesn't seem very secure. He said, no, it's a desktop app. you know, and so the key is that you're developing for things that are running locally and have the local security of the machine. And, but you have all the power of the UX of JavaScript and the, you know, the run anywhere's capabilities. So this hello world literally took me, I'd say 3 seconds. I did the 3 cut and paste into the Node.js environment. They all worked, and it started up in an amazing speed. And to me, that was pretty impressive. When open source works right out of the box without having to do anything is pretty cool. Any other questions?
So are you able to like change the text on that? It looks like it came with like an inspector on the right there.
Oh, this is that's their Hello World app, and I don't know much about it, but it looks a little bit like the inspector from the Google tools. So I think what they were trying to do is teach you a little bit about what you have access to. And I'm sure if there's this, I had a couple of, actually I have about 1,000 other pages.
That's about it. You don't use Chrome.
I do. Just saying that, like, I recognize that from Chrome. Like, are you able to, in that app, like, change the text? By, like,
It's just the browser, pretty much. The problem.
It's the browser.
So,
And
yes.
the other nice part is it was completely detached from the toolbar and multi-tabbing and all these other things. But then people started asking, well, what of the Chrome browser do you have access to in the thing? And it turns out you can, with the package, just enable the other features of the browser, and they just turn on, and then you can give people locality, and they can actually have a tab where they can open new tabs and stuff. So you can take away the security of your Electron app by putting in a tabbed window, and now you might have cross-site scripting and stuff like that. And the other thing that was cool is one of the apps that he had was just pointing Electron as an app to an already existing URL. And that works too. And it just works as a browserless window of that particular URL. So I kind of fell in love with this because this makes some of the intricacies of getting into JavaScript a little bit more easy for me. Anything else?
So when you get ready to deploy your app, have you figured out, like, is it just going to be an exe that you can ship?
Yes, there is I saw quickly that there's a way to create a .exe, and it packages the Node.js, and there's an Electron prepackaged library, and the Chrome, which brings in the Chrome or the Chromium OS or whatever,
Right.
And the whole thing comes in as a package that gets front-ended by an exe, so it becomes a desktop app for the user.
Mike, did you go down to Charlotte? Did you make the Charlotte trip?
I just made yesterday. Yeah, I was down in Charlotte.
How was it?
Yeah.
What size?
As big as you got.
We had bigger.
Okay. All right. Yeah, it was great. We did. There were 3 speakers. We spoke. Dan called for lightning. I suggested lightning rounds at the end because one of his speakers dropped out, and we had one prepared speaker and then another guy who was a lightning talk, but he was a really in-depth talk, and then I just did one of these little bullet talks. So it was very good.
At Watson?
No, it wasn't. Charlotte Watson was like Monday or something like
Yeah.
that. No, I didn't go to that. Sorry, this was Charlotte IoT. So.
Oh, Charlotte IoT, okay.
This is Jacob.
Hey.
He's talking about radar GIF.
Yeah, so it's a really simple
It's
example.
a GIF or GIF.
Josh told me about this a couple hours ago, so I want to show you how to download a radar file from. There's a lot of different sources, but this one comes from a university site. It has a bunch of like National Weather Service stuff on it. And the format of this file is called grid, which is a common weather format. And there's like grid 1, grid 2. This is a grid 2. There's a source for it. And you can see like the year, the day. So you can find 5-minute interval files there. And these files are composite radar for the entire continental U.S. And this level 3 part of it right there, that means it's like it's simplified a lot. Like the level 1 is like the most complicated, and then they have like level 2 files that you can find that are a little less complicated, and level 3 are the simplest ones. So I'm just going to show the simplest example, but you can go there and get it. So the next couple of tools that I'm using here, these all use GDAL, and GDAL is how many people have heard of GDAL? Yeah, so Geographic Data Abstraction Library, and you can do tons of stuff with GDAL. GDAL is an extremely powerful library. And I'm using some command line utilities here, but it's like a library that there's interfaces for pretty much any language. But these command line utilities are really useful too. You can do stuff with them that's really powerful. So GDAL info will just give you some information about the file. And it'll tell you stuff like the projection, because this is a georeference file. And if you do like -hist, you can get a histogram, so you can look at the data inside of that file, try to understand sort of what you're looking at, like even though you can't actually see it in the grid file, because we haven't got there yet. This next thing that I'm going to do is this is a warp. So what I'm doing is warp is meant to like basically change projections or to take subsets of the image, resize them, stuff like that. And this example here is I'm outputting a geotiff. I am setting the output projection to 4326, which is like one of the easiest projections to work with. It's basically latitude, longitude. I'm setting the resampling to bilinear. So maybe I'll work with sampling. There's a lot of sampling options. And I set the coordinates, which I just looked up off of Google Maps for some region around Washington. And I am putting in the input file, and that's my output file. And still can't see that yet because this grid data happens to be a single band, single layer of doubles. So I can't exactly look at that TIFF just yet. But this last line right here, I'm just going to apply a color bar to it. And I'm not showing that color bar, but it's really simple. There's the color bar. And what this tool does, GDAL DAM, it can do a lot of different stuff, but the color relief part of it, it can apply a color bar to some data. And I had on that color bar file listed the data on the left and then the colors on the right. So it was a really simple color file, and so it's just applying that color file. And that's an example of what it spit out. And so the warp basically took a section of it, and spit out just that section. This one actually applied some colors to it, so now I can look at it. And it's still georeferenced, so it's still a TIFF, still has some georeferencing information in there, so you can do some other stuff with it if you wanted to. Or you can just convert it to a PNG. So this is just quickly, I generated a background for it. I was frantically looking for a background when we started, so I found a georeference TIFF here at Natural Earth. You can find lots of data at Natural Earth. Like low-res vector data for the U.S. Like sometimes if you don't want to go to OpenStreetMap for simple maps, Natural Earth is a really good site to go to. You can find Esri shape files and some raster data sets for all sorts of stuff. So I downloaded one of the raster data sets, and that's how I can look at what it was. And then this warp is very similar warp to what I'm doing on the other one, except I'm setting the output resolution. And I'm setting the output resolution to match what the radar output was. And the radar output size was basically like GDAL warp's best estimate from, okay, you're changing the projection and you're cutting a region out of it. And so it tries to guess like what is the best output resolution, but you can change it. And so this is what it looks like. I'll actually show you the source file for that one was, yeah, this is the file I downloaded from Natural Earth. It's pretty high resolution, but for this example, I think I'm oversampling it quite a bit. And I'm going to create a GIF, and for this I'm using ImageMagick. And I don't know ImageMagick that well, I just copy and paste this from an example. So I don't really know what this does, to tell you the truth. But that creates the animated loop and that uses the background. Like, I tried to change some of these, and I wasn't getting what I expected, so that, I know that sets the delay between the frames, and this tells it to dispose the previous frame. Yeah, I'll show you that. Yeah. So I downloaded a bunch of frames, obviously, to put into that. So here's a cool. It's not very high resolution.
Is this weather data?
It's the radar data. So it's a composite. So the radar data, the actual radar sites, they are going around in loops, and they do multiple elevations, and they get like lots of different frequencies of data, and that's level 1. And so go all the way up to level 3, and this is what we're looking at is a composite, all of those stitched together, and not just like stitched together like adjacent radar stations, but also vertically. And so it's like taking a maximum, but it's at certain frequencies, and there's a bunch of filtering applied to it too. Cool.
What's the processing time? Is there, I mean, is this pulling real data?
Yeah.
And it's processing it and rendering it?
Yeah.
Well, this is just an animated GIF now.
Yeah, I know.
Oh,
I'm just wondering,
How long does it take to
how long
those
does it
commands,
take
I
to
guess?
create the animated GIF from raw data from the websites?
I don't know, maybe 20 seconds.
Yeah. Okay.
It's
about as
so
long as it
resolution,
takes
so
for
the resolution of that continental U.S. Data was like, I think it was, I can't remember, maybe like 2,000. We'll look. Oh, I already have it. So the continental U.S. radar data was 4,076 by, oh, yeah. Well, anyways, that's the resolution right there. So it's 5,000 by 3,000, and so the image processing on that, the warp tool is basically reading it all in. The grid file's probably encoded somehow, probably some type of zip for the actual data part of it. And so it's got to decompress that, and then it's got to do a warp operation, which is resampling it to change the projection, which is not really fast the way they do it, but it's pretty convenient to use their libraries to do it.
Yeah.
And then once it pulls out that small image, and creating the actual GIF is, I don't know, it doesn't take very long at all.
So that original grid file,
Yeah.
is that basically like a 2D array of floating point numbers?
Yeah. So grid file has a bunch of grid files can have like a ton of layers in them, and that grid file has exactly one layer. And the level 3 data, you can see that here's a histogram right here. So you can see in the histogram, and there's the buckets, so there's the value range, minus 28 to 50. And these are DBZ values. So if you ever look at like radar, you'll see like DBZ values. A lot of times they map them to like precipitation, but it's not like 1-to-1 exactly. So like light, heavy, medium precipitation. So DBZ is actually like a measure of moisture.
Is it like quantized or something?
Yeah. So the level 3 data, which sucks, all the level 3 data out there is already bucketed by 5 dBz. So the smallest increment is 5 dBz. And you can see like this histogram, like you can see all these gaps in here. And that's what makes the interpolation suck. So this data is oversampled a little bit in this loop. But you can see like it looks a little like blocky. Not blocky, but bubbly. I'm using bilinear interpolation for the warp, which normally is fine. Like you don't see artifacts unless you zoom in a lot, especially when you're doing bilinear interpolation on double data. But because this data is bucketed by 5 dBz, your output just is not great. So you can find if you can find data that has not bucketed by 5 dBz, you get much better output.
How often do we update the grid file?
Every 5 minutes. And you can go to that URL and see all the files. So here's like a bonus here's the a link to the GFS, which is the global forecast put out by the National Weather Service. The radar data and the GFS data and like a few other data sources in the country. It's like what every weather product is based off of. Like almost everything you see from Weather Channel or WSI or anything on the TV is like from these files. So you can pull out temperature forecast data out of these files using GDAP.
So how fast can I go from that data to just seeing it in the GIF file?
I think pretty much as fast as you want. I think seconds, if you really wanted to.
Does it take advantage of GPUs?
GDAL? I think you actually can compile GDAL to use I forgot what it was. OpenCL maybe? But I don't know how much of it uses OpenCL. The warp operation is a little hard to map and do big things. It's like a scatter operation, not a gather.
So what's this one?
This is actually not the GFS, but the continental U.S. forecast. And it's temperature values, and I do colors, and that's a natural Earth state layer on top of it. All with GDAL.
It's temperature and cloud cover?
No, just temperatures. I just pick weird colors for
Okay.
the temperature
That's
value.
a cloud.
This is over 24 hours, I think.
Cool.
But you can
So
also, like in that GFS, there's also multiple elevations of data. So you can get like 40 different elevations of temperature data. So you can render volumes of this if you had a fancy path tracer. But where can we get one of those?
Awesome.
Thank you. What size shirt do you want?
Large.
Thanks, sir. Anybody else want a shirt? You have to talk.
Yeah, sure, I'll talk.
Good.
I didn't want to do this because I don't have any slides, but what the heck, I'll just talk about some of my adventures.
Cool.
Wow, I just started with a very small company. They do automotive analytics, and basically what they do is they help out. You ever go to a maintenance shop at a car dealership, and you know that if you go there, their prices are going to be probably 4 times as high. And the reason why that is they don't know how actually to price their labor. So what the company I'm working for does is help them to price their labor. So they're not charging so little that they're not making a profit, and they're not charging so much that you're going to fret down the road. So anyway, one of the first things that I got into was we get all kinds of data from what they call dealer management systems, and there's about, I think we deal with about 6 or 7 of these, and we get all kinds of formats. We've got web services, we get FTP, CSV files. The CSV files can be really funky because we've got data, we basically got data embedded in data. So my first challenge was, how am I going to deal with this? I mean, we already have a C# application that's basically old and has to be rewritten because it wasn't terribly. It's all tightly coupled. So I'm looking at this thing and I'm going, I need a tool. I need a tool to take care of this. So I can't remember exactly how it happened, but somebody talked about an ETL, several ETL tools. So there are several free ones out there, or at least there's a free version versus a pay-for version. And so we picked 3. We picked Clover ETL. So we heard some really good things about it. There was also JasperSoft ETL, which, has anybody heard of Talon? Okay, well Talon is another ETL. What has happened is Jasper, they've either taken over or they've combined their 2 products into something called JasperSoft ETL. And finally, the last one was Pentaho DI, or Pentaho Kevin. How many people have worked with ETL and know what I'm talking about? ETL is basically extract. I got to be careful with the abbreviations. But anyway,
what were the 3? JasperSoft?
JasperSoft, Clover ETL, and Pentaho DI. Or it was originally codenamed Kettle. I don't know. Pentaho has this thing with kitchens, and they have Spoon, and anyway, I won't go into that. But ETL is extract, transform, and load. And what we had to do initially was we had to extract. What we wanted to do initially was extract data out of these CSV files and just immediately run them into MongoDB as kind of a staging area. And then for MongoDB, we were going to put them into a relational database. So as I was looking at these things, I downloaded Clover. I downloaded all of these. Okay, started working with Clover. Clover and Pentaho both. I was up and running. I was up and doing things useful probably within an hour. Both Pentaho and Clover were very, very intuitive as far as their working. Both of them seem to have fairly good documentation. Plus a bonus, Pentaho had probably 4 or 5 books. I have a Safari Books Online, and I could find at least 4 or 5 books on Pentaho. Clover, they did have good documentation, but not as many books. Now, the last one, Jaspersoft, was a complete disaster. I got it up, I couldn't get it running, I couldn't figure out how to do it, and then on top of that, there was something wrong with they didn't have really good documentation. So it was between Clover ETL and Pentaho. And Clover, even though it was free, was very, very crippled. You could do some really simple things, but it really didn't allow me to do all the things that I wanted to do. Pentaho did, and Pentaho was free. So, yeah, and you had to pay like $5,000 to get the really good stuff from Clover. So I finally decided on Pentaho DI. And it's a great application, very intuitive. It's all drag and drop. And this is all free. This is open source. In fact, all Pentaho stuff. They have a whole BI, business intelligence platform, and it's all open source. The only difference between the open source and the enterprise is that they say that they harden it for production, but I don't know. It's really great if you're really beginning to develop things. You can try it out for free, and we're actually looking at maybe just using the free stuff, because all we really like the data integration piece, which we're going to be using for our import engines. So, and it's I put it through its paces. I put it through some of our worst transformations, and I was able to build solutions fairly quickly. So it has an interesting the way Pentaho works is it builds tables, and as you pass it through the various parts of the transformations, you actually modify these tables and modify columns within the tables. And so you can actually strip away columns, you can add columns, you can pretty much easily pick up Pentaho DI. It's Java based. So and then they also support Python, by the way. It's easy to pick up. The thing you really got to understand is joins and some of the limitations there. But if you understand that, it's an excellent solution. So we're moving forward with it. We haven't decided on whether we want to get an enterprise license. Well, enterprise license for the whole thing is extremely expensive. It's like $75,000 a year. So, but that's basically to embed a full-scale business intelligence software inside your application. So, from there, any questions? Silence.
Yes, I just looked at a list of one of these ETLs, and it says Pentaho is 2.5 stars and Clover is 5 out of 5 stars.
Mm-hmm.
And
I know the answer to your question, by the way. You're asking me what's the difference? It's the way basically Clover's designed. Clover's designed so that when you're using the UI underneath the covers is writing Java code. So it's writing pure Java code. What Pentaho does is it writes XML, and then they have an interpreter that takes and interprets the XML. And we found that it's probably Pentaho is probably 3 times slower than Clover, and that's why people like it. If you want to spend the money for their product right off the bat. The thing is, what I'm using this for is batch processes running late at night. And we ran some time studies and stuff and found that You know, I mean, I could take, we did a 10 gigabyte trial, I think, or I extrapolated out to 10 gigabytes, and we were looking at maybe an hour to run 10 gigabytes of data. So it's not, if I was using something where a user was depending on stuff, that could be a problem. But using this as an import engine in a batch process works fine. Any other questions?
Pipeline options, parallelizing options.
It actually runs in parallel. When you create your process, you create it like step by step, and it looks like it's going to go in series, but it doesn't. If you actually watch it process, it'll start, and then as it moves through, it'll start. More things will start. It actually runs everything actually in parallel.
We should go.
And it does. Yeah, they do have some really good. You can get statistics in that based on you know, which parts of your transformer are taking up the most time. And I'm almost out of time.
What size?
Extra large.
All right.
Thank you. You're welcome.
Sorry, we ran out of beer.
Part two?
Oh, sure. Mark Scott, part 2.
Part 2. Best swag I ever got from a vendor were these little things that you put under your laptop to keep it cool. Also slip resistant.
It's hideous.
Yeah.
Gotta go. I have an emergency situation to deal with, but this is really fun. Thanks for having me.
Sure. We're not getting anything.
You hit your plug in the USB.
USB power.
USB's here.
Thanks for it. The screen rebooted, that's what happened.
Oh.
Yeah.
Yeah. Thank you. Okay. In this part of the lightning talk, I just kind of dovetail on what I did earlier, which is I had a list of stop words, and I wanted to go, I wonder if I'm doing the fastest lookup of those stop words. And I'm going to introduce a new library, which is the bisect library that I'd never used before. I never used inner tools from the first part 1, and I'd never used bisect. So got a function in list that wraps up the bisect, and what I'm doing is a binary search, implementing a binary search algorithm with this library, bisect left. You know about binary search algorithms? Okay. So here was the original stop word list. It's in alphabetical order. I went out and found out how frequently those stop words occurred in the English language, and I reordered this list in the frequency order. D is the most frequent word in the English language, etc. Same list, just reordered by frequency of use of the word in the English language. And then I also created a dictionary object with these words. And there is a file, the Gettysburg Address, 7 years ago, blah, blah, blah. Read the lines, read those lines in. Make sure I clean up the text a little bit, make everything lowercase, get rid of punctuation since I'm splitting everything with a space character. And then I go through 4 different methods of seeing whether the words in the Gettysburg Address were actual words that I'm interested in or stop words. So I'm using the not in for the list, or the has key for the dictionary, and just timing with the time it library. So before and after, stop words by frequency, not in, stop words by frequency. Then I have the dictionary, so if not as key, and calling my function, my wrapper function for binary search, and printing out the times. And the dictionary is the fastest lookup method, followed by the binary search, followed by frequency use, followed by just any old list in any old order. And by the way, the binary does require the list to be in sorted order, so I could just reuse the original list. All of this, like I said earlier, all of this Python code is in the GitHub repository, which I will post. It's TryPython 2016 0226 Lightning Talk, and all of the files, including the Gettysburg Address, are up there.
Why didn't you use a set? Why didn't you use a set instead of a dictionary?
They asked you that when you talked about this the other day at the Python meeting.
Because in your dictionary, the values are meaningless. They're just a bunch of ones.
Right.
Yeah. So that's basically a set.
Okay. Does set use hashing?
Yeah.
Okay. I didn't know that. Yeah. I should.
So it probably performs about the same as the dictionary.
One would expect it to, yes. So if you've got any sizable list to search, do a set or a dictionary or set. If you know the frequency, the most likely thing to occur, that's going to perform just about as fast as as a binary search.
Our sets aren't mutable, right? So that there actually might be a performance.
They're mutable.
Oh, they are.
There's a frozen set, which is
Frozen
not
set.
mutable.
Yeah. Okay.
You can replace a set can you add a pin to or insert into a set?
It's add. It's called add instead of a pin.
Okay. Okay. Maybe I'll do that, update my GitHub project.
Sure.
And of the 200, and some 237 or so words in the Gettysburg Address, after we remove the stop words, we only have 129. So what I was saying earlier, when you get to about 100 of those stop words, you've reduced an average text by half. I told you this was a short one. Any other questions? Right. Ta-da.
Did you get a second shirt?
No, he does not.
No. I kind of knew I wasn't going to get a second shirt. But I did this, but I spoke again anyway.
I remember this after 2-part presentations.
If you presented and you had slides or something, you can share, just post it as a comment, if you would, on the meetup group. And I took a video again, so I'll put that on YouTube so everyone can see it. That's all the talks. So if you want to hang out and chat a little bit, feel free.
Are you gonna post the YouTube on link?
Yeah, I'll put. And last time I added links to each individual talk within the video, so I'll try to do that again.
Where'd you put the link to that?
On the last
meetup?
Thank you for the shirt.
No problem.